All right. Okay. Well, good morning. Happy Monday. Hope you guys are doing well. And I hope your search for data is going well as well. Um, Let me talk about your final project and things to look out for when selecting your data. So I had some slides to posted, but I'm going to hold off on that and instead let me point you to some documents in the final project module. Okay, so first thing is I have added a sheet to our Google Sheets, and this is to sign up for your proposal meeting, your project proposal meeting. So that will be next week during week 6. I've got a bunch of time slots on Tuesday and Thursday. So talk to your teammates and pick a time slot. We will meet for about 20 minutes on Zoom. I need everybody in the group to attend, so please pick a time slot that works for everyone, and we will discuss your data, your project, what you plan on doing, and I'm going to, hopefully I approve everyone's project and say, yeah, this sounds good. But just in case either the data you've brought to me or the project you have in mind, if I have some deep concerns, then I will try to redirect you, or I'll ask you questions, or and if you're not sure, I can. It's intended to help you kind of head in the correct direction. So I'll just say a couple things right now. Don't try to predict the stock market. Okay, if you want to do an analysis of stock market stuff, that's allowed, but trying to predict the stock market, like, it's not going to happen. Okay, it's not going to happen in a 4-week time span between now and when the final project is due. Like, if it were possible, then there wouldn't be the need for all of these financial companies and all of these financial quantitative things. There lots of people are trying to so anyway, things it's a little bit too ambitious, okay? Something like that. But anyway, pick a time slot and I'll hear you out, hear your project proposal. I have put in here, so before, like, whatever you sign up for, you have to submit this project proposal kind of questionnaire, and this is going to be basically a detail of the data set you've selected, and what you plan on doing it. And I have posted both a rubric and the assignment. So this is kind of like a homework assignment. You'll download it, you'll fill out your answers, you'll knit it, and then you'll upload it to this. It should be, and I tried to do it, it should be submitted as a group, like just one person from the group. And I think I have you all assigned in your groups on Canvas or on Brew and Learn, and that when you submit it, it should submit on behalf of everybody, okay? And it doesn't matter which of the group members does it, but that should be the case. So let's go through the questionnaire and the rubric, just kind of real quickly, if you have any questions about it. And then I want to talk about, give you examples of data sets that could be problematic. So let me see if I can download that and open that as well. Okay, so here we go. All right, so the proposal grading rubric. So your project proposal is going to, will be graded, and will count for basically 10% of your final project grade. So I think the final project is going to be worth 300 points, and this part is worth 30 out of the 300. And, if you mess it up, no worries. Even if you get only half the points or something, you can still finish out the rest of the project and get a 95%. So no worries there. Okay, obviously I do want you to try, and that's what we have. Okay, so first you have to submit your questionnaire. Okay, sorry, I should say data and questionnaire sent to the professor at least 24 hours before the proposal meeting. So maybe I have to fix that. But basically the deadline is not actually 24 hours. It's a little bit less than 24 hours. But if your meeting is scheduled for Tuesday, I need it in by Monday, the day before, 5 p.m. And if your meeting is scheduled for Thursday, then I need it the day before, Wednesday at 5 p.m. Okay, so because I'm going to spend Monday and Wednesday evening going over all of your proposals and data sets, and then when we meet, I can ask appropriate questions. All right, you'll be evaluated on credibility of the data source. So I want to see if the source of data is documented and credible. If you are able to answer questions about how, when, and why, or by whom. And so these are all kind of questions on the RMD file over here. So I said, where did you obtain the data? So you'll provide a link to the data. If you got it, and so I'm assuming you're going to find your data set online on the internet. But if you don't, okay, like you're working, I don't know, maybe you have an internship somewhere and that you can get data files or something and they're okay with you, then just let me know, and we can arrange for you to get me a copy of the data in some other way. Okay, so I've got questions about, where'd you get this data, and is the source credible and well documented, how was it collected, and things like that. Now, if you can't answer all of these questions, that doesn't mean you are not allowed to use this data, okay? Because you might have some, even if you get some data from a government agency, okay, which I would generally accept as being very highly credible, like if you get something from Bureau of Labor Statistics or the Census Bureau or, the National Health and Nutrition Survey, okay? I would say, those are all very, very credible. And if you select one of those, you'd get full credit for credibility. It's just perhaps some of these things you might not be able to answer directly, okay? And that's okay. Just because you can't answer every single one doesn't mean the data is not fully credible, but these are all questions that should guide you. And if it's like you can't answer a whole bunch of these questions, then that might mean your data is not as credible, okay? So don't think of this as like every single thing has to be checked off and be perfect, but these are the kinds of questions you need to be asking to decide if this is a data set that you want to work with, okay? You'll want to visually kind of just inspect the data file itself, just like open it up in Excel or Google Sheets or Numbers or whatever, bring it into RStudio and just kind of go a little bit line by line. You might have hundreds of thousands of things, so maybe you can't do every single row, but go through and just say, hey, this looks reasonable, okay? Ask yourself, are there missing values? Almost certainly there will be some missing values, and that's okay. Missing values doesn't disqualify your data set, but if a whole bunch of values are missing, or if you have columns where 90% of the column is missing and it only has data for 10%, maybe you don't want to use that column, okay? And if you don't want to use that column, do you still have enough variables that are interesting, okay? Do you have a strategy for handling the missing values? Do you have a strategy for handling any kind of suspicious or potentially incorrect or unusual values. Real life data is messy, and that's expected. Do we have a way to handle them? These are the kinds of questions I want you asking. All right, so fill this out. Part 3 is going to be kind of maybe the longest part, or I guess it depends how big your data set is, okay? And for each variable, I want you to tell me what kind of data it is, and an explanation of any of kind of the codes or the values or things like that. You can have numeric variables, categorical variables, text, and then date and time. And then numeric, I've further split into continuous or discrete. Continuous basically means you get decimal values. Discrete means only certain values are allowed. There's maybe like American shoe size is like a discrete variable that does have decimals, or I don't know, like you can get a size 8, a size 8.5, or a size 9 shoe. So I guess there is a decimal, but it is discrete. You can't get an 8.73 shoe, okay? So that would be discrete. But generally, rule of thumb is if it's continuous, you're gonna have decimals, and if it's not, it's gonna be discrete, okay? Categorical nominal would be like categories that don't have an order, like paint colors. There's no designated order for that. And then categorical ordinal means there is a set order, kind of like sizes, small, medium, large. Okay. And then text would be things that are like unrestricted. Okay, so and sometimes the line between categorical and text is blurry, but basically, if you're allowed to just kind of enter whatever you want, that would be text. Okay, but if it's like the data collection was poor, you might have things that should be categorical that are kind of classified as text. So, for example, it could be like, what state are you from? That's categorical. Like it should be one of the 50 states or something. But they might have set it so the person just types it in, and so you'll see like California spelled out, or CA, or something like that. Okay, and then you have to kind of clean that up yourself. And then subject knowledge, I just want to make sure somebody's familiar with it, and if you're not personally familiar with it, like, do you have a plan for resources and reading? Hopefully more than just reading up on Wikipedia. Okay, but obviously that's a starting point. If you're not that familiar, you should start at Wikipedia and learn about the subject, and hopefully maybe, I don't know, find some other sources, even if it's like YouTube videos, like gain familiarity. Okay, and then the project scope, I just want to make sure that this is a project that can be completed within our time frame of basically 4 to 5 weeks. So not something overly ambitious like trying to predict the stock market, and but also not something that's just going to be like, all right, we're going to make 3 tables here. Okay, and then I just want to hear your kind of initial ideas for analysis. Obviously not going to be done. This is a proposal, and that's what we have there. Okay, so talk with your groups about what time slot works for everybody, and then put that in there. The Thursday later ones are always more popular, but if you've got a data set and you feel like you're ready to go, propose for Tuesday, and you can get started right away. Okay. All right. Okay. I wanted to also go over examples of data sets that could be, say, examples of problematic data. Oh, okay, and this is the, I guess, grading criterion. So you can go through that, the grading rubric. So I want to go over a few examples and just point out some of the things. So as you are, I imagine most of you are new to data analysis. You might not be familiar with some of the issues to look out for. And so I wanted to kind of go through each of these things, show you, just talk about some of the problems that, let's go there. Okay, so this is, I've talked about this data set before. It's a popular data set. It's got around close to 1,900 upvotes, and you have, there's a bunch of example notebooks. So on Kaggle, you have the data. You have people also share their notebooks where they've done some initial analysis, and you are allowed to look at what kind of analysis other students have, or other people have done. That's like, I can't stop you from looking at things on the internet, okay? And so you might get some ideas, some discussion where people ask questions, like this is a good, like how are the data points collected, okay? And some of these things will reveal to you, oh yeah, these are problems, right? It says the data set was inspired by. So anyway, the issue with this graduate admission data set, so let me go ahead and click download. Download the data set as a zip. Oh, you know what? I have it already downloaded. Okay, so we have a whole bunch of numeric variables and whatnot. The issue here is that you want to ask, what is the source of the data, okay? And a lot of kind of information is provided, hopefully, on your the data card, okay? And this part says this data set is inspired by the UCLA graduate data set, which I did a search for, and I found it over here. This is from the Computing Center, and they did an example of logistic regression, and this is kind of an examination of whether somebody gets admitted or rejected, and here it says the description of our data. It says we have generated hypothetical data, okay? And you are able to obtain this from the website. But basically, you would not be allowed to use this data because it's not a real data set. It's just generated, okay? So anytime you see the words where it says we generated the data, we simulated the data, I don't want you to use that, because an important part of doing data science is dealing with the dirtiness of real life data, okay? Now, if you go to a government website, probably a lot of the data will be clean, and so you can avoid some of those issues. But almost every other kind of data set, there's gonna be like weird things that you have to watch out for. And simulated data, you're not gonna have any of the weird things, and also like models are just going to fit too perfectly to simulated data. So, so that's a data set with a problem. Okay, another data set is this data set that it says the Google Play Store apps data. Okay, and it says this information was scraped from the Google Play Store, and so I guess they went on the it's like the App Store but for Android, and they downloaded like information about each of these things, and at first glance it looks okay, and there's a couple files here, okay, but if you look closely at the data, there's a bunch of data quality issues, right? And so these are the kinds of things that do require you to kind of go a little bit like line by line through some of these things. And I mean, obviously, here's there's 10,000, okay, 11,000 lines. So you can't do every single one, okay? But some of the things, just kind of, if you take the data, like some of the things you should do is like say, okay, well, if I have something that looks kind of like a name, all right, what if I sort, okay? And if I just take this data set and I say, hey, let's just sort by the name, okay? And as you kind of go through, you'll start to see, oh, you know what? We have some duplicates, okay? We have the same thing, the 2017 EMRA Antibiotic Guide, the 21-day meditation experience, okay? And you start seeing some of these things are duplicates here, okay? And so we have, 365 scores, live scores. I don't even know what that is. It's probably like it's a sports app, okay? And what is this? Last update, current version, Android requirement, stuff like that. And these two rows are nearly identical. The only difference is this column, the number of reviews has changed. Okay, so the number of reviews has changed, but basically you have these duplicate rows. And I don't know exactly what happened. I imagine what happened is the person started scraping the website, got some data, and then they let it run for a while, and then they came back the next day and they scraped the website again, hoping to get something else, but ended up scraping some of the same information. And so you end up having this duplicate stuff, all right? And so what do you do? So, the existence of duplicates, I wouldn't say disqualifies the data set, but I want to have a strategy for how you're going to handle this. So what you would need to do is you would need to say like, okay, if we see two rows with the exact same thing and the only difference is the number of reviews, maybe we'll just keep the one with the most reviews and we'll delete all other entries, okay? And that's fine. That seems like a reasonable strategy, and I would just kind of like delete this. Now, you'd probably want to try to write a script to handle that, and that could be a lot of work because you don't want to have to do this for 11,000 manual entries and look for this, okay? There are other kinds of things where it's like, is this the same app or is this are these different ones? So you have 30-day ab challenge, 30-day ab challenge LumaWell, 30-day ab challenge free, and it does seem like these are indeed different apps because you have different kind of like ratings and different numbers of reviews. So it does seem like these are different things and not straight duplicates. But yeah, here is 8-Ball Pool. Yeah, I don't know what happened here. This one showed up a whole bunch of times. Okay. And so what are you supposed to do with this? Yeah, probably just keep one of these rows only. Okay. So that's a quick way to just kind of check the quality of your data is just, if you have something, just say like, all right, let's take this column and just sort, okay? Sort by name and just see if certain things show up multiple times. It could be like, if you sort by name and it's people's names, there could be two people with the same name, right? You could have two Alan Smiths, and that might not be unusual. But you want to know, okay, you look at the other variables, is this a duplicated person or is this two separate people, things like that, okay? So again, duplicated data doesn't eliminate or disqualify the data set, but I want to hear a strategy for handling it, okay? Here's another example. This is the Spotify songs attributes. This is like a fun data set. The problem here, okay, is we have these different, this was released by Spotify, okay, and it says there are a bunch of columns. 13 of these are song attributes. One column for the song name, one for the artist, one and a column called target, which is the label of the song. And then it says there are 13 track attributes: acousticness, danceability, duration, energy, instrumentalness, and things like that, okay? And the issue here is that these ratings of acousticness, danceability, energy, okay, duration, that makes sense. That's like how long does the song last, okay? But these other things, there is some proprietary internal algorithm that generated this score, okay? And when I asked for a little bit more detail and I said, hey, what's the underlying meaning of these metrics, okay? What is the difference between a danceability score of 0.3 and a danceability score of 0.6? I don't know if anybody could answer, right? And so this is going to be a problem because, sure, we might find some kind of trend in the data, but what does it even mean? Okay, what does it mean for a song to have high danceability versus low danceability? Okay, we like to think that maybe it means it's more danceable, like it's easier to dance to the song, but I don't know. What does it mean for a song to have a danceability of 0.98, and how is that more danceable than something else? Okay, so I don't know. This is so I would want to know these things. If there's a couple variables that you're not able to explain, that's fine. But if it's like a whole bunch of these variables you can't explain, I want to make sure there's at least enough variables remaining that you can still do an interesting analysis, okay? So again, you might not be able to explain every single variable. You might have a data set with like 70 variables and, like 10 of them, you have no idea what they mean. That's fine. That leaves you with 60 variables that you can explain that certainly you can find some interesting trends in relationships. Okay, but if it's like 70 variables and you can't explain 65 of them, all right, yeah, that's a problem, okay? Student knowledge of the subject. So, these are interesting data sets. There's this red wine quality data set. There's a chronic kidney disease data set. And basically, so the chronic kidney data set comes from the UC Irvine Machine Learning Repository, which has some really interesting data sets. Okay, and a lot of them are reliable. Again, go through the checks and make sure the sources of the data are good. But I don't know if, do any of these things mean anything, okay? BP for blood pressure, specific gravity, albumin, pus cell clumps, okay, I guess. What are these? Okay, what do these variables mean and how are they related to chronic kidney disease? And, some of you might have familiarity with, some medical contexts, and that's great if you are. But if you're not, I would strongly caution you against working with data that you are unfamiliar with, okay? Now, if you're willing to kind of read up and study and learn about these things, that's okay. But yeah, I want to make sure somebody is at least either familiar or knowledgeable or has reliable sources that they can learn from to get these things, okay? And again, another example I use is one of the best projects I saw, or I don't know about the best, but a very good project I saw was when people did some esports data. I think they were looking at League of Legends games, and one of the group members was a very avid League of Legends player, so was very familiar with like all of the different heroes and all of these different properties and things like that, and they had a good analysis. And then another group did also League of Legends data, but none of them played, and they said, I have a friend who played, and I guess they asked some questions about their friend, and they actually brought the friend to the final project report. And but their analysis was just very weak, and I ended up kind of asking questions like, "What did you think about this, or did you think about that?" And the friend said, "Oh yeah, that would have been good for you to analyze," but the friend wasn't directly part of the analysis, so they missed out on a lot of these things. Okay, all right. I hesitate a little bit to put this one in here because it is a really interesting data set. It's a challenge. Okay, so this top 1000s in IMDb. I have seen good projects based on this, right? I have seen a good project based on it, but I've also seen, I guess, a couple bad projects based on the data. And let me pull this up and just try to show you what. How do I get this down? So this is based off of IMDb, the top 1,000 movies list. Okay, so the highest rated movie on IMDb is The Shawshank Redemption, The Godfather, The Dark Knight, Schindler's List, 12 Angry Men, Lord of the Rings, Return of the King. And let me open up the Kaggle data set. Okay, and this is what the data look like. And so we have the title, the year, the certificate, runtime, genre, rating, Metascore, detail, which is kind of a short summary of what the movie's about, the director, and then some of the actors, and then the number of votes, and then the gross box office. There's also, this is the rating on IMDb, and then the Metascore is another website with movie ratings and things like that. Okay. So what is the problem with this data set? Okay, so I would say not a direct problem, but there will be certainly a lot of challenges. Okay, and that is a lot of the interesting variables are very text based. Okay, the other variables that we have that are kind of numeric that you can kind of work with are year, runtime, rating, Metascore, votes, and gross. Okay, so the natural thing is to think like, okay, is there a relationship between the rating of the movie and the gross box office? Is there a relationship between the rating on IMDb and the Metascore? Is there a relationship between runtime and gross? Or you might wonder about any of these things. Okay, and I think asking is there a relationship between the rating on IMDb and the rating on Metacritic? That's kind of a boring analysis, because the answer is going to be, yeah, if it has a high score on IMDb, it's going to have a high score on Metacritic. Okay, these are basically just like, I think the only kind of interesting thing you can try to pull out is there, which movies has a significant deviation between IMDb rating and Metascore, and can we find a pattern for why these things are so different? But in general, if it has a high IMDb rating, it's going to have a high Metacritic rating, and if that's your analysis, that's not that interesting. Okay. Other things, okay, so certificate is kind of like the rating. this has all kinds of issues because it looks like they're mixing in ratings from the United States and Europe and things like that. So, in the US, our movie rating system is, rated R, rated PG-13, rated PG, rated G, things like that. And in other countries, it's like what age. So Shawshank Redemption in the US was rated R. In whatever country has this certificate, it was a rated 15, okay? The Dark Knight in the US was PG-13, and in this country was 12A, okay? This one, that Pulp Fiction, is 18 or something, okay? So I don't know what U is, unrated, maybe, okay? So that's gonna require some cleanup, okay? The other thing that's a popular kind of choice is like, okay, well, is there a relationship between rating and gross box office, okay? And so naturally you'd think, yeah, probably. There's a few issues. One is you're gonna have to correct for the year, okay? So making $1 million in 1950 is quite a bit different from making $1 million in the year 2000. So that's something you're going to want to have to correct for. Again, these aren't disqualifying things, but these are things you have to think about, and it's going to add complexity and challenges to the data. Okay, and then the other issue is because we are limiting ourselves to the top 1,000 movies, the lowest rating that we have is a 7.6. Okay, the lowest rating on here is a 7.6, whereas there's lots of movies on IMDb with like ratings of 5 and a 4.3, and just like what we would say is a bad movie. But these are the top 1,000 movies, and so our range of rating is very small, going from 7.6 to 9.3. That's a range of basically 1.7 points. So you're trying to do an analysis where the difference between the absolute highest and the absolute lowest is 1.7 points on a 10-point scale. And that's going to kind of limit the kind of analysis you can perform. Another thing that you probably will have a hard time finding is, once you limit yourself to just the top 1,000 movies, there's probably not going to be a strong relationship between rating and box office because, again, we're limiting ourselves to just the top 1,000 movies. A silly analogy that I like to use is there a relationship between a person's basketball playing ability and their height? Okay. And for the general population, the answer is absolutely yes. If you are a taller person, you will have an advantage at playing basketball, and if you are a shorter person, you will be at a disadvantage at playing basketball. Okay, and that's just generally going to be the trend. So if you look at high school players, yes, people who make the team will be taller. People who don't make the team will be shorter. Okay. However, if you look at NBA players, okay, and you ask, is height related to basketball ability? And you have some way to measure basketball ability, say how many points they scored or something. Is height related to how many points they scored? The answer is going to be no, okay? Because once you are in the NBA, everybody is talented at playing basketball, and generally, most of the players in the NBA will be very tall. There are a few players in the NBA who are under 6 feet tall, and they're considered like, some of the shorter players. But overall, most of your players will be over 6 feet, over 6'4" or whatever, and you're not going to find a strong relationship between height and basketball playing ability. But in the general population, absolutely, there's going to be a trend, but just in the NBA, you're not going to find that kind of relationship, okay? So a lot of the interesting variables are text-based, okay? And text-based variables are just very difficult to kind of work with. All right. Genre. This has some challenges because it looks like some movies get listed in multiple genres. So you have crime, drama, action, crime, drama, action, adventure, drama. So I said I saw good analysis, and they did a lot of text cleaning and preparation where they kind of took this genre and they separated them all out, and they pivoted the data so they could find all of the movies that had a drama genre, all of the movies that had crime, all of the movies that had action, and they were careful to kind of make sure that they were just looking at one of these things at a time, so that you wouldn't get a whole bunch of duplicates and things like that. Okay, this director column and the actor column is a little bit tough. Okay, so for example, we have like The Dark Knight, directed by Christopher Nolan, and then the number one actor on the thing was Christian Bale. Number two actor, Heath Ledger, Aaron Eckhart, Michael Caine is number four. The order in which the actors get listed is a little odd, and I'm not 100% sure. Probably requires pivoting the data, and that's fine, okay? But sometimes a movie is directed by two people. So for example, The Matrix was directed by the Wachowski sisters, and you have Lana Wachowski and Lily Wachowski, except because there were two people, these two people, Lily Wachowski gets listed in the actor one column, which for whatever reason is missing the heading. But yeah, that would throw off the analysis, right? So this data set, I would say, is very interesting, but presents a lot of kind of challenges. And I would want to make sure that any group that says they want to use this data has a strategy for addressing these challenges as well. And so these are the things I want you to think about when selecting your data set. Make sure you have a strategy for dealing with some of the different aspects. And so my hope is that the questionnaire that you will fill out for your project proposal will guide you through those questions, and that, yeah, you'll have a good project proposal lined up. Okay, so meet with your groups, sign up for a time slot for your project proposal, and good luck as you go searching for your data. Yeah, question?
Do we need to do the slideshow?
Yeah, the view quiz. I totally forgot about that. You know what? We'll just cancel today's view quiz, or I don't know. I'll give you the answers. Okay. There are three of them, and actually I forgot. Let me check. So today the answers are E, B, and A. Okay, so these are your three answers: E for number one, B for number two, A for number three. And thanks for coming to class. Thanks for tuning online. And yeah, good luck as you search for your data. And we'll see you Wednesday.